Good day to all of you. Now, in this slideshow, we will discuss a very preliminary primer of a linear programming example. There is a company which manufactures two types of paints, P and Q, and each type of paint needs two raw materials, A and B. And every unit of P is sold for 1,000 rupees, every unit of Q is sold for 1,500 rupees. There is a cap on the availability of A and B, or the number of units of A and B available to us per day. Thus, as a manager, one would need to optimize the number of units of P and Q to be manufactured in order to maximize the profit. You will see at the bottom of this slide, Z is equal to Z is the objective function, and that is equal to 1000x plus 1500y, where x is the number of units of P manufactured per day and y is the number of units of Q manufactured per day. And here the word VAR is not exactly variance, it is variable. And the daily availability of A and B are given as 30 and 50. Thus, from this contingency table, we will form the constraints. Plus y is less than or equal to 30 is the first constraint. X plus 3y less than or equal to 50 is the second constraint. Drawing the constraints on the graph, we will first of all notice that x and y cannot be negative, thus the constraints are confined to the first quadrant only, and the line AB will be representing the first constraint, x plus 3y equal to 50, and this line B and C represents 2x plus y equal to 30. They meet at B, which is 814. The meeting point, the point of intersection, can be ascertained by solving the linear equations. If you notice, the area ABCO is our feasible region. It is the region which is it is a convex set, and as per our rules of mathematics, the extreme values of z will be observed at the corner points of the set. It is a quadrilateral. Since extreme values are observed at the corner points, we will check out the value of z at each of the corner points. So at A, 0, 50 by 3, z equals 25,000. At B, 8, 14, z equals 29,000. At C, 15, 0, z equals 15,000. Thus, if you really see, the solution is at B, 8, 14, and maximum possible value of z is 29,000. It's a very simplistic procedure, this graphical method of solving the linear programming. If you have two independent variables and an objective function comprising of a linear function of these variables, it is comparatively easy to go into such a procedure. However, if in case of more than two variables, you will definitely face a problem.